Hello, my name is Brandon Clayton, the Algebra Guy, and as you see on your screen today, we'll cover simplifying square roots with variables. So we'll work our way up to there so we can answer the question you see on your screen now. Simplify the negative square root of 81y squared. How do you do this? Let me show you step by step just how to do that. So the questions we want to answer today is how do we simplify expressions with square roots? How can we estimate and approximate a square root? How can we simplify variables with expressions in the square roots? And how do we solve square roots in actual application or word problems? So without further ado, let's get to it. So the first thing we want to talk about is, do you know why we use the word square? You know, if you've ever heard someone say 3 squared or 4 squared, why do we say square? So if we construct a square, which I've done here to the right, with 3 tiles on each side, the total number of the tiles will be 9. Well, what do you mean? 3 tiles on each side. So let me get my tool out here. And so let's do a rough drawing. So we're going to do 3 tiles here on each side. So I did 3. Notice I'm dividing it into sections of 3. And another one here. So there we go. So now this is why we say that the square of 3 is 9. Can you see why we say it's 9? Because when we make this side 3, we're saying we're dividing this into 3 rows. And when we make this side 3, we're saying we're dividing into 3 columns. So, and you can see that all these tiles are going to add up to 9. We have 9 squares here. The number 9 is called a perfect square because it is the square of a whole number. So if I took a whole number like 2 and I squared it, that'll give me 4. So 4 would be considered a perfect square. Now if I did 2.4 and squared it, the answer I get is not going to be considered a perfect square, but only those that have whole numbers that are squared. Like 4 squared gives me 16. So that's why we call this squared, because we're literally taking, it's the thought of a square and each side being the same, and we're finding the area of that space is taken up. So if I were to continue the perfect squares, you could see here at the bottom of your screen that if n, some number, some whole number, were 1, it'd be n squared is 1. 3 squared is 9, 4 squared is 16, and so on and so forth. All these will be perfect squares, which are important to note because they will come up again in many discussions going forward. So know what the perfect squares are. They're easy to deduce just by taking that number and multiplying it by itself. 5 times 5 is 25, 7 times 7 is 49, and so on. So if you were to look at it as a formula, here's how you will see it. If n, which is some number, and you square it, so we took some number and you square it, is going to be equal to m. And that m is the square of n. So let me reiterate that here by drawing it out. So if this is our n, that's not the best color. So this is our n, 5, and we squared it. The m we're going to call is the square of n. So 20, we're going to say 25 is the square of n. I know that's messy, but I'm trying to say it as well. So I just want to make sure we get that foundation and basics down before we go forward. What about a negative number? What if you took a negative number and squared it? Negative 1 squared, negative 2 squared, negative 3 squared. Well, I do want you to notice that and remind you that negative times a negative is a positive. So saying negative 4 squared is negative 4 squared is going to equal 16. It's still going to come out a positive number. As a matter of fact, if I were to pull up my chart that we just saw a second ago, you'll notice that all the answers are still the same. 25, 25, 36, and 36. Why? Because negative times a negative still gives me a positive, so nothing is going to change there. However, I do want to offer a bonus, a kind of tip here, because you notice that I put parentheses around this negative 4. And the reason I did that is because that's important, because had I written it this way, your calculator and different assignments will understand that to mean 4 squared is 16, which is negative. So without the parentheses here, you're telling, when you put the parentheses, you're saying I want to take that whole thing inside the parentheses. Negative 4 times another negative 4 is a positive 16. Now without it, it's not going to work. So I just want to save you some frustration. If you're trying to use your calculator and you put negative 4 squared and you keep getting a negative 16, you're like, this isn't right, this is not working. Well, because the calculator is thinking you're saying 4 squared and then multiply. So it's doing the PEMDAS, it's doing the exponent first, and then it's multiplying this negative, which is like a 1 right here. So keep that in mind, how the calculator is thinking, or if you see it on the test, it needs to be, remember the difference between those two. Sometimes we'll need to look at the relationship between numbers and their squares in reverse. So we talked about going 3 squared is 9, but what if I went backwards? So because 10 squared is 100, we say that 100 is the square of 10. But we can also say that 10 is a square root. That's an important word. If I want to work backwards, 10 is a square root of 100. Just like 100, let me get a different color. Just like 100 is the square of 10, 10 is the square root of 100. So if I were to write this out and using that same formula, a number whose square is m is called the square root. So we'll say, in this case, n is, if n squared is m, then n is a square root of m. So whatever this number is here is just called the square root. So let's do another example. So if I put 3 here and squared it, that gives me 36. So I can say 3 squared is 36. What am I talking about? 3. And you guys didn't correct me. Don't let me say that. 6 squared is 36. So I would say that 6, so it says n is a square root. So here's n. So I would say 6 is a square root of m. So what's m? 36. So 6 is a square root of m. So that's how I would think of that when you think backwards. And we're going to practice more with that. But also notice this important feature. Negative 10 squared, as we just mentioned, is also 100. So negative 10 is also a square root of 100. Therefore, both 10 and negative 10 are square roots of 100. So I can have 2 possible answers. Why? Because negative 10 squared would give me 100, and 10 squared would give me 100. So every positive number has 2 square roots, 1 positive and 1 negative. So here's my square root notation. M is read as the square root of m. M is read as, and we just talked about that up here, the square root of n is read as square root of, I believe I should have wrote n. Radical sign, and just to get this, because this may be your first, or you may be new to seeing this, because this is not something that you use until you get to later on in math, which is at this point if you're watching this video. But this square root sign, right, this piece right here, that's the square root. So this is our square root sign, this is the radical sign, and the number under here we call the radicand. So radicand, and there's a number here also that's understood always to be a 2, which you'll talk about much later, which is called the, actually I can't remember that name of that, but there's just know there's a 2 there that we always understand. I'm showing you again what it looks like if you break it down. The square root of 100 is 10. Why? Because 10 squared is 100. And the square root of 121 is 11. Why? Because 11 squared is 121. You could also say, obviously, negative 11 squared. So it has 2 options there if you're going to look for what the square root of 121 is. All right, let's simplify these. What's the square root of 25? In other words, what number squared gives me 25? Well, that's 5. 5 squared gives me 25, because 5 times 5 is 25. What about 121? What number squared equals 121? Not 122, 121. So it got to be the same number too, right? So 11 times 11 gives me 121. So it must be 11 squared that it gives me 121. But also remember that these can be a negative answer. It can be 11. My answer here can be 11 or negative 11. So now we understand from this point on, we're mostly going to be talking about positive. You see this radical sign just like this. We're just going to be discussing the positives for the most part. But know that there's two possible answers, 5, -5, and 11, -11. Not too fast. All right, what about this one? What if I have a negative sign here? How do I handle that? So I'm just going to ignore that negative sign for a second and do the square root of 9. Well, what times what gives me 9? What number squared gives me 9? Well, it's going to be 3. So now I'm going to add the negative at the end to be a -3. So the answer for this one is a -3. So I ignored it. Same thing I'm going to do here is the square root of 144. So some number squared equals 144. That's going to be 12. N is going to equal 12. So I know that this whole thing right here is equal to 12. And now remember to put the negative on the outside as a -12. So don't let that negative confuse you. Now there is a time when you do want to pay attention to this negative, and that's now. Can we simplify the square root of -25? In other words, is there a number when you square it that would give me a -25? Or let's think about it in the square. Is there a number that the square can have on a side, on each side, that is the same, when multiplied would give us a -25? Well, you're probably thinking no, just because of the way the question is set up for one, but hopefully you're realizing 5 times 5 is going to be a positive number. Negative times negative is going to be a positive number, and I can't switch them because it's a square. It has to be the same exact number. And it won't make sense anyway to have a -5 and a 5. Well, what does a -5 side look like? It just doesn't make sense. So does that work? No, it can't. We cannot find a real number, I'll say for now, a real number that's going to make that work. So this cannot be solved. Later on, there'll be such thing called an imaginary number, but not in the scope of Algebra 1 will we be discussing that, or pre-algebra. So we'll leave it just like that and say there is no answer that will solve that problem. Negative square root of 25. Square root of -25 rather. So same thing with this one. Square root of a negative number. There's no number squared that's going to give me squared that's going to equal -169. Because I can't get a negative after squaring some negative number. It's going to make it positive. Just not going to work. So no, that's not going to work. But this one will, because notice that the negatives on the outside, square root of 121 is 11. And now I can include that negative on the outside, and that will work for this one. All right, let's think about the order we'll work these in. We have square root of 25 is 5, and plus the square root of 144 is 12. When we add those two together, we get 17. Well, isn't it the same thing as just putting it all together like this? Well, let's check. 25 plus 144 is 169. So that leaves me the square root of 169. Well, what times what? So what number squared equals 169? Well, it comes to find out that 13 times 13 will do that for me. Let me double check that. 3 times 3 is 9. It's 3, 3, 1. 9, 6, 1. So 169. So if I took 13 and I squared it, that will give me 169. So my n for this one will be just 13. So the square root of all this would equal 13. So is my answer the same? No. So be careful not to just assume that, oh, I just add 25 and 144 and square root that. So it does matter how it's presented. So far, we've only worked with square root that are perfect, right? 2 squared, 3 squared, 4 squared. But what if I gave you this one? What's the square root of 5? Well, hopefully you would think for a second and think, well, I know the square root of 4 is 2. And I know the square root of 9 is 3. Square root of 5, it must be between 2 and 3. And I would agree with you. It's between 2 and 3. So whatever it is, it's going to be some kind of decimal, right? 2 point something. And would that be closer to 2 or 3? So would you have a really low decimal like 2.1? Or would you have a higher decimal like 2.8 or 9? Well, you can obviously see how much closer it is to 2 and by its vicinity. But How could we see that? That becomes important later in just trying to estimate the value of that. And let's work that on this problem. Estimate the square root of 60 between two consecutive whole numbers, and which perfect square is it closest to? Let's estimate it. So when estimating, I like to jot down my perfect squares on the side of my paper. And anytime I'm working with perfect squares, I would encourage you to do the same. Just to give you a reminder of what the perfect squares are. 16. So you don't have to recall them all the time. So I just write this on the side of my paper. And it makes it easy to glance at later. Now I'm all the way up at 60, so I'm just going to jump down. I'm going to get closer to 60. So I'm going to use, let's get to, where are we? Already there. So 49 squared is 64. There we go. So the square root of 60, so I got 4 is 9, and the 60 is going to be where? 60 is going to be somewhere in between here. So I know the number is going to be a 7 point something because it's between 7 and 8. Now it's going to be closer to 8 or 7. Well, let's look at it. So 60 is in between 49, is greater than 49, but it's less than 64. So is that number going to be closer to 49 or 60? Well, hopefully you're seeing it, right? 60 to 64, there's only a difference of 4. And here there's a difference of 11. So there's a difference of 11 here and 4 here. Well, obviously it's going to be closer to your answer. That's the square root of 64, which is 8. So it's closer to 8, meaning that it's higher than 7.5. So it's going to be 7.6, 7.7, something like that. So that's a good way to estimate it. So we answered our questions, we estimated it, and we found out which was its closest to. All right, let's round these. Let's round the square root of 17 to 2 decimal places using the calculator. Now, sometimes you're simply going to be given a calculator and asked to round these numbers. So let's become familiar with how to do that. I'm going to pull up my calculator, and we'll work those together. Now, depending on what kind of calculator you use, you're going to put this in differently. But for my calculator, I have to put the number in first, then press square root. For other calculators, like if a graphing calculator, you put square root first, then the number and enter. So just know how to use your calculator. All right, round square root of 17. So square root of 17, I'm going to put 17. And I'm going to look for the square root sign. And I see it right here. Now, I told you there's a 2 there. They went ahead and made it. This is a cube root, and which we'll talk about another time. But right now we're dealing with square root. So what's the square root? And it's right there. So 2 decimal places, 4.12. So we look to the, this is a 2 decimal places. So we look to the second decimal place, and to the right we got a 3. So we don't round up. We keep it just as it is, 4.12. Now, we just worked a problem a second ago that talked about the square root of 60, and we rounded. Now we have a calculator out. Let's, for kicks and giggles, let's figure out what that would have been. So let's put in 60. And we estimated that it'd be higher, it'd be closer to 8 than it was to 7. We said 7 point something. So let's look at it. And there it is, look, 7.7. So being able to do that in your head and just kind of thinking about those numbers is pretty nice. To say square root of 60 is not only going to be 7 something, but I can get pretty close to about where it is in a decimal, about 7.7, just from knowing that it's closer to the square root of 64. So pretty cool. All right, what about the square root of 13? And this is just calculator work at this point. Should be able to put that in the calculator pretty easily. So we got 13, and we press the square root button, and there we go. Get 3.6. And I notice the second place is a 0, but to the right is a 5, so it goes up 1 to 3.61. And lastly, square root of 11. Erase this. Get 11 square root, and that gives me 3.3. And I have a 1 in the second place that it says 2 decimal places, and to the right I have a 6, so that goes up to a 2, 3.32. Now, lastly, I want to talk about variables. Simply simplifying variable expressions with square roots. So let's consider this. What is the square root of 9x squared, where x is greater than 0? We're not going to make it negative. Can you think of what the expression would be whose square is 9x squared? Well, let's take one piece at a time. Let's take the 9. What would be the square root of 9? Well, the square root of 9 is 3 and 3. So what times what would give us a 9? We said it would have to be 3. N would have to equal 3. But what if I also did the x that way? If I said n squared equals x squared. So what does n have to be to get an x squared? Well, hopefully you can see that these look really close. The only thing that's different is the n, so I need an x squared would give me a x squared. So what that's saying is that if I take x times the x, it'll give me x squared. So 3 times 3 give me 9. X times x will give me x squared. So the square root of 9x squared is simply 3x. I just took the square root of each term, the 9 and the x squared. Let's do this one. So we actually did this one already, right? Because we talked about how if we had a square and we knew that the area was x squared, or in other words, we knew that some number squared was x squared, some number over here, that would have to be x, because x is one side of the square, there is x. X times x is x squared. So we'll know that this is equal to x. And what about this one? Now I want you to pause it and see if you can work this before I do. Square root is 16x squared. Again, I think about a square. That helps me a lot because I'm a visual person. And I think about the square root of 16. Well, that's 4 and 4. And the square root of x squared. So that's 4 and 4 give me 16. Well, how do I get an x squared? Well, x times x will give me an x squared. So I know that my square root is 4x. Why? Because 4x, all of that squared is going to equal 4 squared is 16. X squared is equal to x squared. And again with this one, I want you to try it. It helps me again to draw I'll draw a square. And to ask myself, what times what gives me 81? And saying it that way makes it easy for me to realize that 9 times 9 is 81. And y times y is y squared. Or in other words, 9y, when you square the whole piece, is going to give you 81 y squared, because 9 squared is 81 and y squared is y squared. All right, same thing here, but we have another piece that was added on, but it's still going to be same idea. So if I drew a square and I took out each piece, I said 36, well, that'd be 6 times 6. Well, how do I get the x squared? Well, we've done that many times at this point. It's going to be x times x to give me that x squared. And what about the y squared? Well, I need a y times a y. So what is the square root of 36x squared times y squared? That's just 6xy. Why? Because 6xy, when you square this whole thing, which means this times this, is going to give you this area. 6 times 6 is 36. X squared is x squared. And y squared is just y squared. All right, let's do one problem in the application. Mike and Michelle want to make a square patio. They have enough concrete for an area of 200 square feet. So we're talking about area. So let me make a patio. I kind of have a picture down there, but I want to make sure this square is not misunderstood with this different angle down here. So they have enough concrete area for an area of 200 square feet. So I'm going to go ahead and put 200 in here because I know we're talking about area of this square. To the nearest tenth of a foot, how long can a side of this square be? Patio be? So they want to know one side. Well, in other words, they're asking us, what is the square root of 200? So let's make this, instead of a question mark, let's do it algebraically and say, we don't know that side. What times what is going to give us 200? And it has to be the same number. So they're really asking us, what's the square root of 200? How do we find that? Well, we're going to take out our handy dandy calculator. and we're just going to put it in our calculator. So come on, Mr. Calculator. We're going to do 200, and we're going to do square root, bam, right there. So square root, this is I better not say equals, because it's not equal. It's approximately equal to, because this decimal keeps on going and going and going and going, and it's not a perfect answer, but if we're going to round it to the nearest tenth of a foot, we're going to say it's 14.1. That's the tenth place. We look to the right, it's a 4, so we need not do anything else. It's approximately 14.1 feet. I didn't have to put feet under there. Oh, yeah, actually that was good. 14.1 feet. So that's approximately what it is. Now, how do I know this is an approximation? Because if you take that same number and you try to multiply it by itself again, it doesn't come out correctly. So if I don't know if I can do that. If I can highlight. Okay, I'll have to let you do that. But if you take this same number and let's say I square it, I should get 200. Good. So I get, because that's in the calculator. But if you take it and you cut off that decimal anywhere, it's probably rounding, but it's going to be like 1.9 points, something. So you want to say approximately, because that's really not going to be a perfect answer. All right, guys, thanks for tuning in. We're going to ask these questions. Did we cover everything? What is a rate and ratio? How do we write a rate and ratio as a fraction? These are not our questions. Our questions were different. So let me go to our questions. We had questions like, because I want to make sure I didn't miss anything. All right, how do we simplify expressions with square roots? So we talked about simplifying these expressions with the square root, and that was simple, right? Because I just gave you square root of 36, and you said that was 6. So that was easy. How can we estimate an approximated square root? We did that by drawing out all our perfect squares and seeing which number it came closest to. With this square root of 60, we said it was closest to, it was between 7 and 8 and closer to 8. How can we simplify a variable with the expression? The same way we did a number. We asked ourselves what times what gives us that x squared. And that would be x. The square root of x squared is x. How do we solve square roots in the application problem? We saw that with the fence problem. They want in the area of 200. With one side, it would have to equal about 14. We just took the square root of that. Again, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next class.